Okay, everyone, this is Mr. Spiels. I'm going to be helping you out with your lesson today, and I want to be the first to welcome you to a new chapter. So, if you've been following along in your book or in Big Ideas, you'll notice that we finished chapter 7, and now we're going to be moving on to chapter 8. Before we start chapter 8, though, we need to kind of take a step back a little and just do a quick review of solving proportions, which you would have learned previously in algebra, but it's important to have those skills before we move forward. So that'll be today's lesson. So our essential question is, what strategies are used to solve for missing values in a proportion? And then your assignment is going to be the practice problems that are posted. There's also going to be an answer key posted so you can check your work and make sure you're doing it right. And then when you're done with that, log on and make sure you submit your Google form so your teachers can give you credit for doing the assignment, okay? I think the best way to do this to start is just to remember or to kind of review what proportions are and why we talk about proportions, okay? So I've got two circles here. Let's pretend these are like two different cakes, okay? One cake is chopped up or divided into 4 slices, 4 really big slices. And then one cake is chopped up or divided up into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8, right? So if you were told that you could have half of a cake, right? If you're looking at this one, let me just shade in half of this cake. You could say that you're basically eating 2 out of the 4 pieces of cake, all right? That's called a ratio. 2 out of 4 would be a ratio. Okay, I'm eating 2 out of the 4 total pieces. If someone said to you, you could have half of this second piece of cake, okay, so if I were to shade in that second half, or that second piece of cake, I'll shade in half of it, that would be 1, 2, 3, 4 out of 5, 6, 7, 8. That would be 4 out of 8 slices that I would be eating, right? That's another ratio, 4 out of 8. But what we do know by looking at these is these are essentially the same thing, right? If you look at this, if you look at these drawings, whether you eat this half of the cake or whether you eat half of this cake over here, it's the same thing. It's just chopped up into a different amount of slices. So something like this, I think we would all know, would reduce to 1/2. 4 out of 8 would also reduce to 1/2, okay? These ratios that are equivalent are called proportions, okay? So that's what a proportion is, okay? Taking 2 ratios and setting them equal to each other, okay? So let's use that background knowledge, and what I'm going to do is go through 3 or 4 examples with you guys. So the expectation is that you're taking notes through these examples on your own note sheet, so that way when you're doing your practice problems and your exit ticket, you'll be able to look back and know how to do this, okay? So example 1, I'll let you guys write this down. It says 6 over 9 is equal to 10 over what? Okay, so on all of these problems that we do today, we're going to have a variable that we're solving for. Okay, we want to figure out what is 6 over 9 equal to. 6 over 9 is equal to 10 over what? Okay, so thinking back to strategies to solving proportions, one thing that you may have picked up in algebra class is that when you're solving, especially when you have a fraction, a variable in a fraction, one of the strategies there is to multiply by the reciprocal on both sides, okay? That word reciprocal hopefully sounds familiar, basically taking a fraction and flipping it. Well, if we take this fraction and flip it and multiply that on both sides, what you're essentially doing is you're cross-multiplying, okay? It's kind of a quick shortcut here. We're cross-multiplying. So what I can do is I can say 6 times x is equal to 6x, and I'm going to set that equal to 9 times 10, which is 90, okay? So multiplying by the reciprocal on both sides is the same thing as cross-multiplying and setting your 2 values equal to each other, okay? So the key behind all these problems is figuring out what our variable is. So we just have one step we have to do here. I'm going to divide by 6, and when you do that in your calculators or in your head or by hand, you would get x is equal to 15, okay? So we know that 6/9 is the same thing as 10/15. Okay? All right, so that's example one. You may have examples, or you will have examples on your practice and your exit ticket today that looks something like this. So example 2 is 6 over x minus 1 equals 4 over 7. We're going to use the same strategy the whole way today. So we're trying to find our x, right? So what we're going to do, same strategy as before, we're going to cross multiply, but now we're going to take all of that in the denominator, and we're going to set it equal to 7 times 6. So the way I would write this is 4 times x minus 1, and that's equal to 7 times 6 is 42. Okay, so this one's going to require a little bit more work. Hopefully you're looking at this and you're just remembering that you can distribute this. So this is going to be 4x minus 4. Don't forget to go to that second number. A lot of times people just like to put minus 1. Don't forget to multiply those two. Is equal to 42. And now we're just a couple steps away from finding our value for x. So I'm going to add 4 to both sides. So I have 4x equals 46. Now I'm going to have to divide. And I have 46 divided by 4. When you do that, you get x is equal to, let's see, 11.5. Okay? And so if you were to plug in 11.5 for x, okay, these two ratios would be equal to each other. That's our proportion. Okay? All right, let's do 2 more. This one, slightly more work. So again, we're going to follow the same strategy. And again, just pause this video and write this down when you need to in your notes. I'm going to cross multiply here, cross multiply here. And I'm going to say 4 parentheses x plus 9 is equal to 6 parentheses or times x plus 5. And now the key here is our variables are on opposite sides of the equation, right? So we want to eventually get those on the same side of the equation so we can solve for x. But first, before we do that, let's simplify. What I'm going to do is distribute. So it'd be 4x plus 36 is equal to 6x plus 30. Okay. Let's bring our x's together. So I'll say minus 4x from both sides, minus 4x. Remember, if we have an equal sign that is separating our variables, we can't just combine those. We can't just say 4x and 6x is 10x. We have to make sure we get the variables on the same side. Consider this equal sign like your wall that you have to cross. Okay? So this would be 36 is equal to 2x plus 30. Okay, and again, I want to find what x is, so I'm going to leave that right there, and I'm going to subtract, bring my constant over to the other side, and I'm going to have 6 is equal to 2x. One more step, I'm going to divide, and I get 3 is equal to x. Okay? All right, I do have one more example for you, and again, I'll have you guys just jot this down in your notes. You will see a couple word problems on your worksheet today and on your exit ticket. And I just want to read through this with you and go through a really good strategy for setting these up. So the first one says 1 inch on a map represents 50 miles. Okay, if the distance from Milwaukee to Chicago on that map is 3.5 inches, how many miles is it? Okay, so let's think about this. You're looking at a map, and on that map, every time you measure an inch, that represents 50 miles in real life. Okay? So when you're reading these word problems, immediately look at the first or second sentence and pick out your first ratio. Okay? It's telling me 1 inch is representative of 50 miles. Okay, this next part is key. To set up your next ratio, you want to make sure that your units are the same. Okay? So if I have inches on the top here, I need to have inches in the numerator here. If I have miles in the denominator here, I need to have miles in the denominator here. So I should have inches to inches, miles to miles. Okay? So let's see what the question is asking. If the distance from Milwaukee to Chicago on that map is 3.5 inches, how many miles is it? So that tells us right now what we're looking for. How many miles? We don't know how many miles. That's what we're solving for. But we do know that it's 3.5 inches. Okay? Again, big key, make sure your units are the same. If you were to put 3.5 down here, you're going to get the wrong answer. You got to make sure your units are right. Okay, so what I'll do is I'll cross multiply. Okay, 1 times x is 1x, or you can just write x, is equal to 50 times 3.5 is 175, and x is equal to 175. All right, divide by 1 is the same thing. So x is equal to 175. I think what I'll do for this last one is I'm going to have you guys write this down in your notes. Pause the video when you write down this problem and try to solve it yourself. Okay? So write down the problem, try to solve it yourself, pause the video. In about 2 or 3 seconds here, I'll pick back up, and hopefully at that point, when you hit play again, you'll be ready to check your work. Okay? So if you did the problem and you're checking your work, let's give this a try together. It says a recipe for cake uses 4 tablespoons of butter and makes 10 servings. Okay? So like we talked about in the last problem, first or second sentence usually gives you your first ratio. 4, I'm going to write TB for tablespoons, makes 10 servings of cake. All right? 4 tablespoons, 10 servings. What are we going to set that equal to? How many tablespoons are needed to make 30 servings? So if I have servings down here, I'm going to need to put servings down here. And it says how many tablespoons? That's what we're looking for. We don't know how many tablespoons. Okay? So once we cross multiply here, I'm going to say 10 times x is 10x. And I'm going to say 4 times 30 is 120. And when you divide this out, you get x equals 12. And what are we using here? How many tablespoons? So it's going to be 12 tablespoons. Okay? Hopefully these helped. Your practice problems are going to be very similar. Please don't hesitate to reach out to your teachers if you have questions.